Alright, so in this video we are going to cover section 1.6 notes. So you can locate this in your chapter 1 packet. And so the rest of section 1.6 is going to talk about odd and even functions. So graphically, if you're trying to decide if something is an even function, and notice it doesn't mean even power. Now with this one it happens to be an even power function, but with this one it's just the absolute value of x. With this one it's cosine of x. So I'm not referring to even power. This is something different. And on a graph, something is going to be an even function if it is symmetrical over the y-axis. So each of these examples you can see, if you were to fold the left or the right side over the y-axis, it would fold right on top of itself. And the reason why this is significant is because of the inputs and outputs. So for instance, if I plug in 2, I will get out 4. Now this symmetry occurs because if I plug in -2, I will also get out 4. And so for even functions, it doesn't matter if you plug in a positive or negative input, they're going to have matching y values either way. So same thing with absolute value. If I were to plug in 3, I would get out 3. If I were to plug in -3, I will still get out 3. Now cosine is kind of previewing before we get into trigonometry, but we'll notice that cosine is an even function as well. So I won't get into specific points there, we'll save that for later, but again has that symmetry. So another way to say this is basically that if we plug a negative number into f of x, it's just going to equal the same output as if we plug in that same number but positive. And so that's going to help us decide algebraically. So if we don't have the graph already for us, we can test this theory right here. So let's go ahead and formalize this. And so a function is even if and only if f of -x equals f of x. Okay, so to test this, we are going to plug in -x, simplify, and see what happens to the function. Now it's important that you use parentheses right here because this negative is going to be squared. And so a negative times a negative we know to be positive. And so when we simplify this, I end up getting a positive x squared. And this -5 is unchanged. So if you compare our final result to the original, you'll notice that they're the same. That means it is an even function because plugging in any -x value will keep my function, my outputs, exactly the same. So kind of like what we were talking about on the graphs up here, plugging in negative inputs are going to give me the same output if I were to plug in that positive. So moving forward, now let's look at odd functions. And so these three are all examples of odd functions. And this time graphically, it has symmetry but about the origin. So looking at a couple points, if we were to plug in 2 into x cubed, we would get out 8. Now if I were to plug in -2 I get out -8. So the outputs are the same value, but with opposite signs. So I got an 8 again, but now it was negative when I plugged in a negative value. So something similar, again, looking forward, sine is also an odd function. Again, I'm not going to give specific points here, but whatever this x value is gave us some y value. And now I know if I were to plug in that same x value but negative, I'm going to get the same y value but negative. So another one that we could look at, this would be the point 1, 1. That means this point would be -1, -1. So algebraically, we would say that a function is odd if and only if you plug a negative x into the function, it gives you the same exact output back, but opposite. So again, if I plug in a positive x and get out +2 and get out 8, if I plug in a -2, I'm going to get the opposite back out, which is a -8. And so we can test this by again plugging in a negative x value. Again, it is important that you use parentheses around that negative x to make sure that you are doing your order of operations correctly. Also, simplifying these with the exponents. And as I say that, I missed parentheses right there. So we have negative x times negative x times negative x. And so since we have a negative being multiplied 3 times, that's going to result in a negative. So that first term becomes -5x cubed. The second term, we're subtracting a negative, so becomes positive. And if you compare this now to the original, every sign changed. So we could say each term is opposite now. And that's what this formal definition is saying. If you plug in a negative x value and you get out the same function but opposite, it's going to be an odd function. Okay, so now to look at some examples. We're just going to classify them as even or odd. So first one, hopefully you see that symmetry over the y-axis. This one is even. Number 2, just looking at it, a lot of times students think that it's odd just because it has this curve right here and it has a curve over here also. However, if you picked a couple points and rotated them, so like for instance, I'm just going to guess and say that this point is 2, 0. That means that another point should be -2, 0 if it has that symmetry. And you can see that it doesn't. You could pick another point. You could call, like this one for instance, maybe 1, 1. That means that another point would have to be 1, -1, which again, we're not seeing over here. And so if you were to rotate this around, it does not fold onto itself. So this one we're considering neither. For the third one though, this does have rotational symmetry. And so you can kind of see these points that have been mirrored or rotated around. And so this one is considered odd. And with the last one quick way that you could decide if it's even, odd, or neither is to graph it. However, I will ask on your test that you will do it algebraically. And so again, to test it algebraically, we're going to plug in a negative x, simplify it, and see what happens. Use parentheses. Keep in mind a negative times a negative times a negative is still a negative, and that'd be x cubed, and this negative 1 is unchanged. So notice that the x cubed was positive, now the x cubed is negative. However, when you look at this negative 1, it was already negative 1. And so now since you have part of it that changed and part of it that stayed the same, this one we call neither, even or odd. So if you were to graph it, you wouldn't see any symmetries on the graph.